Hi, everyone. I'm Dan DeMers. I'm the CEO and co-founder at Cinchy. Today, we're going to talk about collaborative intelligence and how the emergence of data fabric technology unlocks the next big shift. Just quickly, a little bit about me. My background prior to founding Cinchy is I used to work in a bunch of big global banks, predominantly in capital markets, building enterprise systems for some of the largest and most complicated financial institutions in the world. So my daily life kind of looked like this in terms of my failed attempt to really organize all of our knowledge and all of our information. But my experience is definitely not unique to me. This is a universal challenge for every company on the planet. And you've all heard the expression that data is the new oil. Well, it's not. Data itself is actually useless. The reason that you need data, though, is that's the only opportunity you have to extract intelligence. And intelligence is the real prize. That's what ultimately everyone is actually after. So how do we actually get intelligence? Well, there's a great muse that exists in nature, and it's right here. It's our brain. If we take a step back and think about how the brain works, how does it generate intelligence and manage information? Well, there's a couple of interesting facts here. The first is that each of your brains is managing more data than the biggest, most complicated company on the entire planet. Think about that, and it's a nice efficient form factor. So how does that work? As you learn more, why doesn't your head run out of space? Well, how that works is that every time you're learning new information, your brain is actually reorganizing itself. It's not a fixed schema where you're simply inserting new rows of data. It's actually changing the schema. It's evolving. It's forming new connections as you learn. And that's quite key. And that change continues all the way up until the end of our lives. It doesn't stop. And that's what some refer to as the neuroplasticity of the brain, the ability for it to really remold itself and reshape itself. And there's been a recent study that concluded that individuals with a higher IQ actually have more efficient neural networks. There are fewer connections between neurons. So if you think about that, that's incredibly insightful when you start to think about the equivalent of an enterprise. What does the enterprise brain look like? And how can we achieve the same level of capability for our companies? Well, the key there is the idea of plasticity is really what unlocks and enables intelligence. If your brain didn't have the capability of reorganizing itself, our intellectual ability would be largely fixed from the date of our birth. And while newborns are brilliant in that, they can tell you when they're hungry, they can tell you when they're tired and whatnot. There's a pretty substantial difference there when they learn to walk and talk and grow up and contribute to society. And again, that is enabled because of the plasticity. And when we talk about the human brain, there's really two forms of plasticity. The first is structural. So that's the ability for the brain to reorganize itself and change the schema, the data model, as it learns through life experiences. And the second is really around the resiliency of it, which is called functional plasticity, is the ability of the brain to remap where information is managed and really work around any damage to keep the brain operational and highly available. And these two together form plasticity, which again is that enabling technology for intelligence. So how would we architect our applications with this capability for plasticity? Well, the traditional old way, regardless if you're doing monolithic apps, client server, three-tier, n-tier, service-oriented architecture, microservices, the pattern is fundamentally the same as your application, whether you buy or build, whether it's micro or macro, whether it's a mainframe, whether it's on-prem, whether it's in the cloud, they all have their own data store, and they all require you to do integration. And that data store has a fixed, rigid data model that you can't change. One of the first lessons that I learned when I was a developer, an entry-level developer in a bank, is you just don't go into the data model and start changing it because you're going to break a bunch of things. All the APIs that are dependent upon that, all the external integrations, the UI, everything's going to be your data abstraction layer. You add, you work around, you don't refactor. And that's in the context of a single application. Now imagine in a complex company that has many thousands of applications. Some of the companies that I worked at had 10,000 plus applications. That's 10,000 rigid data models. That's a whole lot of rigidity. How do we actually architect the new applications that we're building in a better way, such that it's built for plasticity? Well, there's a couple of variations here. The first is the introduction of data fabric technology allows us to avoid that point-to-point integration, essentially enabling the virtualization of plasticity. And that allows applications, whether they already exist or they're going to be net new, whether you buy or build, to have the ability to map to a semantic model, where that semantic model itself can evolve free from the data model that exists inside the application. Now, that is virtual, it's not physical, meaning if the data model inside of these applications were to change, you're going to break that virtual layer. So the next level of agility here is actually to make that physical, so that there is physical plasticity built into the machinery, into our architecture, such that we're not so much building applications, we're building experiences, which is really why we have applications in the first place. It's about the interface, it's about the business logic, it's about the rules, not because they can store data and access data. That's a means to the end. That's not why we buy them. So the ability for data to be managed in its physical form in a structure that allows for plasticity, meaning that schema can evolve, is what we call autonomous data. So that is data that is born on a data fabric. It is free from being imprisoned inside of an individual application. And the fabric's design is such that it builds that plasticity capability into the software. It allows you to do something as simple as rename structures, change data types, merge entities, break entities apart, and give you that ability to evolve the schema almost as if it were a living organism. So the traditional approach is one that results in extreme rigidity within an application and across applications when you look at it at an enterprise level. So when you have existing applications and you're adding new ones, the conventional approach is that the new ones, again, regardless if it's a microservice, macroservice, on-prem, SaaS, same pattern, is going to have an app-specific data store with an app-specific data model, and that is going to be very rigid and hard to change. And you're going to uh, essentially do APIs to connect applications together so that you can enable code reuse. Think of that as a code fabric. And while that makes a ton of sense, alone, that doesn't actually negate the need to do integration behind the scenes, because behind that code is data, and the data needs to come together. And data cannot exist inside of a service boundary without ever interacting with other data. That's not possible if you've ever attempted to do a kind of a puristic microservices architecture at scale. You realize that it's not the solution to the data problem. It's actually the solution to the code management problem and the decomposition of applications into separately deployable pieces of software that are easier to manage and maintain. But the data integration continues to consume half of the IT budget of pretty much every organization on the planet. So that's not itself the answer. That's the result of the rigidity. So if we apply that new architecture when we're building new applications or enhancing existing applications, either through virtual schema plasticity surrounding existing applications, or physical plasticity by building new applications without building new application-specific data stores, where that data is managed natively on the fabric, what that ultimately enables you to have is that semantic model in the middle that gives you that plasticity. And as we said earlier, plasticity is a requirement for true intelligence. Think of the beginning of the enablement of intelligence, and it's very exciting when we see big organizations really start to become intelligent. And that benefit happens pretty much immediately. But while plasticity is enabling intelligence, you can't have it without it. It itself doesn't guarantee it. It's not like you just suddenly change your architecture and now you're an intelligent organization. It needs a supporting methodology on how you gather and grow and organize your intelligence. And there's really two core design patterns there when you're thinking about how to design for intelligence. The first is what's called collective intelligence, where you have essentially a shared brain, a central information store that leverages non-autonomous agents, which could be people, it could be machines, where they don't have autonomy, to contribute knowledge back into the central, and they are controlled by that central brain. So if you've ever watched Star Trek and are familiar with the Borg, think of that as an example of collective intelligence. And there are many other examples in our real world today where the result of a SaaS business model to trap data, it's really creating this collective intelligence paradigm. But there actually is a better way, which is collaborative intelligence, where it's similar in that it's a multi-agent system, but in this pattern, the agents have autonomy, be those individual machines or actual people. And the machines could be, of course, artificial intelligence. But each is autonomous in that they are able to contribute into a problem-solving network, but they retain control over their information, over their data, and over their own kind of individual intelligence. And if you ever are thinking kind of the difference between collaborative versus collective intelligence, well, again, going back to the Star Trek analogy, if you ever watch that, the Borg always loses. The evidence is there that collaborative intelligence will always win against a collective intelligence. And I'm personally just very confident in that. No one wants to live in a society where we're controlled by the collective. And collaboration isn't a new concept. It's already conquered the enterprise. It's new for the world of intelligence, but how we work on documents, how we message, how we meet, how we deliver projects, these are all examples over the past decade where collaboration has been massively disruptive and boosted not only control, but also productivity and efficiency of organizations. So applying that same concept to data and overall intelligence is really it's inevitable. And that is made possible thanks to data fabric technology. So data fabrics are a new paradigm. If you follow any of the industry analysts like Gartner, Forrester, G2, 451, others, there's a lot of talk and a lot of hype, frankly, around data fabric, but it's rightfully deserved. It represents the first major shift in pretty much 40 years. The last big shift was when we moved from monolithic mainframe systems to distributed systems, which largely started with the introduction of the relational database by a company called Oracle in 1979. So we moved from a central platform to a distributed architecture where there's an app for everything and a database for every app, therefore data fragmentation, and it caused this whole kind of cascade. While net it's still better, it was left with its own problems, as we know from the fact that we consume half of our budget on integration, as an example. So the emergence of this new technology is what enables collaborative intelligence to actually happen. If you're unfamiliar with the data fabric, the easiest way to think of it is if you're familiar with the concept of data virtualization, which is software that creates really an abstraction layer that hides all of the fragmentation and duplicate data and whatnot behind its configuration. But the data in its physical form continues to be fragmented. It continues to require point-to-point integrations. The virtualization provides that access layer to simplify the usage of that, largely serving analytical use cases, but it doesn't change the game. It doesn't make it so that it is actually that way in the real world. So what I want to do is show you just a quick example of a data fabric and bring that to life. So I'm actually logged into our own environment. At Cinchy, we use Cinchy to run the entire company. We even go as far as to build the next version of Cinchy inside of the current version of Cinchy. It has what we call a meta architecture, which is pretty cool. But I'll show you what a data fabric actually looks like. So one of the built-in experiences, what's called My Data Network, that allows you to really interact with all of your active metadata. And right now I'm logged in as myself, Dan. I'm only seeing what I have access to as an individual user, meaning any other person's view into the fabric is derived based on the access that they have been granted from whoever ultimately owns each individual cell of data. So the cumulative effect of all of that access creates this experience. And what I'm seeing is really our company's brain. Like if I zoom out, there's all of our knowledge through my access lens. But if I zoom in, what are these actual nodes? What are the neurons here? Well, that's the actual data set. So as an example, I have employees. And it's larger because it's more connected than some of the other objects. And it's this mustard color because it exists inside of a domain. And you can see that domain links back to human resources. So if I just navigate through the entire domain, you can see there's all of our HR related data. Think of that as a subnetwork or a subfabric. And I can search for any particular piece of data. So for example, if I want to find people, just looking at all contacts, I can see, I can locate that. Think of this almost like a Google Maps, but this is the satellite view, and I can get directions and see its connections to any other data set. And you can see when I zoom out, data is just all connected. It's quite a natural phenomenon. But I can go further than the satellite view. I can go down to the street view, and I can even open up that data. And depending on my access level, I can see, change, approve, delete, and manage that data. So what I'm now looking at is rows and columns that exist inside of our contact repository, where you can see we have just under 15,000 records, and this contains our employees, our prospects, our investors, and so on and so forth. But as I navigate through, so for example, if I want to click through to a company, I'm now looking at that company's company record. And if I close out of the street view, go back to the satellite view, you can see it's just I'm basically able to kind of pop in and peek into any particular piece of data. And again, today is September the 21st, and we're looking at the present, but I can even go as far as to go into the past. So if I go back to the beginning of time, I can see the really the day we installed the platform and seeded our data fabric with the meta model, where there's a single table called tables. Then the Big Bang happens, creating all the control tables. And then we, just like our customers, started to use it to solve real business problems, where the fabric itself grows as a result of accelerating those very same projects. So we don't run a project to build the fabric, and neither do our customers. So this is just an example of a real live data fabric, and I'm going to show you a little bit more in a few minutes. But let's get back to the present. So back to September 21st, 2020, and you can see that our fabric has evolved quite a bit in the 2 years that we've been really building it out. But we were getting value pretty much right out of the gate. So let's go back here. So it all probably sounds very cool, but how and why would you actually use it? What does a data fabric going to actually do for you at the end of the day, other than kind of look pretty on the screen? Well, if you think of, if you've ever been in a position where you're managing a portfolio of applications, I have myself, you were often left with really two extreme choices. You can maintain that application, or you can rebuild it. And if you think of it in the context of a house, there's a pretty substantial difference between throwing some paint on a wall, doing some minor repairs, versus destroying and recreating the entire structure. Those are extremes. So when in the world of housing, there is a middle ground, which is really the idea of augmenting, to allow you to stretch the functional capabilities of your structure, adding a new floor, adding a new room, adding a pool, all these changes that you can make. But you're building off of the foundation that's already there, but you're building it to match your new and evolved requirements. So that idea of being able to augment an application is equally powerful, and is now suddenly possible by connecting existing applications to a data fabric. So the one way to think of it is, if you think of how augmented reality connects reality and gives you a richer, more intelligent experience through the power of connected data, well, an augmented application is the same. You can take an application like Salesforce as an example, connect it to a data fabric, and suddenly it's more intelligent. And I'm going to show you an example of that. The difference here is that these applications are now connected not to each other, but to the fabric. And the fabric is like a living organism. It's evolving, it's getting smarter. So as more and more solutions leverage the fabric, either to manage data natively or to simply connect in their data to enable that plasticity that we talked about earlier, that fabric is getting smarter. And any application that's already connected to it now has access to that. So we're talking about basic network effects, similar to how the internet today is more powerful than it was yesterday, because there's more information that's evolved, and that evolution continues. So we're going to show an example of how you can augment an existing application, in this case a CRM, and apply the benefits of collaborative intelligence to make it smarter. So we're going to use Salesforce as an example. Now, just one thing to note is that for us in our business, we use nothing but autonomous data, which includes for our CRM functionality. So while we've connected Salesforce in, it's really dummy data that we're using for the purposes of this and other demos, but you'll see that it's side by side with our real data that we use to actually run our business, where we don't need an application. So using a traditional CRM wouldn't add any value for us. In fact, it would take away a lot of the value that we get by not needing a siloed system. But the first thing we would do is we would use the built-in connectors through a simple configuration to map the data from its representation inside of Salesforce. In this case, we're just using a vanilla org model, as if it's a fresh kind of install of Salesforce in the cloud. And we're mapping that to our semantic model, where we're mapping it to a data set we call people. So people in our fabric maps to contacts inside of Salesforce. And we've already done that mapping. That took about 30 minutes to do, but it's already done. So we'll just show you how that works. So the first thing I'm going to do is actually go into Salesforce, and I'm going to add a new contact. And I'm going to give it a name. So let's say it's Bart is the first name, Smith is the last name. And let's say Bart works at ABC Inc. and he is the CEO. And I'm just going to paste in the email address. So Bart at full contact, and I'm going to go ahead and save that. So notice that I did not supply a LinkedIn URL or any other social data, and gone ahead and save that. And if I go into the details, you can see there is that record. There's Bart at ABC Inc. But let's now check it out in the fabric. So back into Cinchy, let's search for our data set. In this case, it's called people. I'm going to locate that. There it is. I'm going to open it up. And now what I'm going to see is that record that I just added in Salesforce. And there it is, row number 1. And I'm seeing it side by side with the 15,000 odd rows that we have that are our actual data, this being the one fake record. And in our own internal processes, we just filter out anything that is originating from Salesforce, knowing that that is demo purposes. But you can see here, this got ABC Inc. It's Bart. There's the email address, and there's the title. So that was step 1, and that is actually a bidirectional connect. So you can see, for example, that the tags field is actually editable, unlike some of these other fields. So I'm going to actually go ahead and populate that. So I'm just going to pick a tag. Let's just say it's related to the data fabric category. So I'm just going to make that one data change here inside of the fabric. So I'm not making that change inside of Salesforce. So the first step was to enable the bidirectional connectivity. In this case, we did a real-time in and a 60-second polling sync out, just to demonstrate that it can work both in a batch mode and a polling mode, as well as a real-time data streaming mode. So the end result of that is the data in Salesforce is available in real time on the fabric. But as you saw, it was side by side with data that actually originated inside of Cinchy as autonomous data. And that includes entire rows of data, but also columns. And where we have an autonomous column that can be extended even on top of connected data. So we were able to enrich a record that was originated in Salesforce with a field that was originated inside of Cinchy as autonomous data. But we didn't stop there. The next thing we did beyond enabling autonomous data and the blending is the connectivity with social data. And in this case, we plugged in a service called Full Contact, but we used the built-in connectors that are part of the fabric to connect this in and really orchestrated the enrichment of the record that originated in Salesforce or originated as autonomous data. It's now universally applying that regardless of the source. So what it's doing is it's taking the email address and retrieving LinkedIn as well as Twitter and a few other social URLs. And then based on that, we can then use that social data and plug in another service. In this case, we're using one called Crystal that applies artificial intelligence to that social data to determine their personality profile. And that personality is key because we can factor that into lead scoring and various predictive models that we have inside of the organization. We also wanted to be able to pull in all the interactions that we have with them, regardless if it's over the phone or via email or via text or others. So we use a service called Copper, which can also double as a CRM. We just don't use it in that capacity. We really use it just for interaction tracking. And we've plugged that in a similar way into the fabric to enrich that record, regardless if it's coming from Salesforce or not. And then finally, we use another tool called Outreach for email automation, marketing automation for email sequences. And we wanted to be able to have that information seamlessly connected into the fabric. So the fabric is really interweaving all of these threads to create that tabular view. That tabular view is not only readable, but it's editable depending on your access controls. And it's now disconnected from the applications. So let's go back into the record here. Well, if I actually go to the right a little bit, so let me just refresh this. And if I scroll to the right, so you can see there's our friend Bart, and there's the tag that I populated. But as I go forward, you can see that there's a whole bunch of other fields that can capture the enriched attributes that are doing so in a fully automated way. And if I go back into Salesforce, and let me now just refresh this record, you'll remember that I made a change to the tag, and you can see that the tag is now propagated into Salesforce. And you can see there it is, Data Fabric. And if I change, let's say, the title to, maybe if that was a typo, maybe it's actually the head of sales. And I'm going to change, I spelled his last name, it's not Bart Smith, it's actually Bart I don't know, Jones. So I'm going to make two changes here. I'm going to save that. If I go back into the fabric and refresh that, because that's actually a real-time link that we have coming back in, you can see that now it's head of sales, and you can see that it's Bart Jones instead of Bart Smith. But unlike the ability to do this inside of the legacy system, inside of Cinchy, I can go to a collaboration log and I can see the full history of change. So you can see this record was originated in Salesforce. We then enriched it with me making a change, adding the tag, but then it was modified inside of Salesforce, where you can see it was changed from Bart Smith to Bart Jones, and the title was changed from CEO to head of sales. So it's actually adding value to the data beyond its core capabilities because it's now on the fabric. It's version controlled, it's access controlled, it's fully traceable, automatic lineage, automatic governance, data classification. All these things are really just built into the fabric, so that you don't have to worry about it as an after the fact. So the way to think of it is just think of how you think of a sweater, where there's a collection of threads that are interwoven, where one of those threads is what rises to the top, and that's what you see. So think of every data set as really a set of threads. You got rows, you got columns, horizontal, vertical threads, and ultimately one thread rises to the top. So that could be Cinchy in the form of autonomous data. It could be Salesforce, it could be Outreach, it could be a mainframe, it could be a delimited file, it could be a REST endpoint. It doesn't matter. Ultimately, you as the builder of the fabric are the one that makes that determination. Now, the value in this simple scenario of connecting Salesforce and augmenting it with this new capability is that we've added new features and functionality. So in this particular case, we simply did an auto enrichment with social data and personality profiling, but we could have, there's no limits in terms of what we were able to do because it's connected into the fabric, and that fabric is really that source of intelligence powered by Plasticity. And the other thing that we've done is we've unlocked that data. So we're able to interact with that data without paying for the huge licensing and consumption fees that are typically associated, especially when you're talking about SaaS software, where largely your data is trapped behind a paywall. The other thing that we've done is in this scenario, none of the applications have any dependencies on each other. They're completely decoupled. They're really disposable because the data is under your control, and each of these applications is connected not to each other, but to the fabric. And the fabric is kind of like that network in the middle, just like how I'm connected to the internet, and through that one connection, I'm connected to billions. It's that same layer of abstraction. The other thing, by connecting to the fabric, you saw how it was doing data version control automatically, and that's just one example of the additional controls that are built into the fabric, but those are now automatic and they're universally enforceable across the fabric, no matter how I'm interacting with it. One final thought is don't forget that applications lead to data fragmentation. Fragmentation is what forces us to do integration, and integration is the cause of great suffering. It is why our data is trapped and siloed, and requires us to do integration, which consumes half of our entire IT budget every year, and that's true for every company on the entire planet. Data fabrics are a very new paradigm. There's a lot of hype around them. If you follow any of the industry analysts like Gartner and Forrester and G2 and 451 and others, there's a lot of mention about that. And with any hype, there's lots of confusion. So one of the things that we've done recently is stood up a new learning series that we hold live every Thursday. And if data fabrics are of interest and you're looking to double your IT capacity and get control and unlock the power of Plasticity, I'd encourage you to join. It's cinchy.com/learn. You can join us live. You can watch the recordings after the fact. You can look at historical episodes. And if the platform is interesting, you can also, through this link, just book a live demo, and we can have someone walk you through the platform and explore potential fit. So thank you. I'm Dan. We are Cinchy. Cinchy is a play on the word cinch, which means simple. And what makes our technology unique is it represents the beginning of the end of integration, which otherwise consumes half of the IT budget of every company on the planet. Thank you.